If you want to build software products that are both secure and high-performing, you need a strong foundation that can deliver both. The combination of seL4 and NVIDIA hardware can provide just that. While the seL4 microkernel provides a secure foundation for software products, the NVIDIA TX2 and TX NX platforms are powerful hardware solutions that offer high performance and features for a range of applications, including AI, robotics, and autonomous applications. In this interview, DornerWorks embedded engineer Chris Guikema will explain how seL4 was ported to the NVIDIA platform and what this combination can enable in your products. How did you port seL4 to the NVIDIA platform?
Basically, I got put on the project maybe when it was already halfway through. So there was already quite a bit of work done, but they were having some issues specifically with virtualization that they thought I could help out with. seL4 already supports the TX2 platform upstream. So it wasn't like we had to go through and create an entirely new port by ourselves. We were able to leverage a lot of what was already existing. Similar to how with Xilinx, they release a new version of their toolchain, a few times a year. NVIDIA does the same thing. And one of the issues that we were noticing is that behavior was kind of a little sporadic. Things weren't working properly like the way we were expecting it. So I came in and I kind of cleaned up some things so that way everyone was working on the same page. And I discovered that the NVIDIA bootloaders and tool chains and everything were making modifications to the device tree. So the stock device tree that the seL4 kernel was using didn't match the device tree that a running version of Linux was using. And this is a problem because specific memory region carve-outs that were overlapping with regions seL4 was trying to use. There were devices that had been modified or removed. It was just kind of, it was a little crazy, let's just put it that way. So basically what I did is I pulled a version of the device tree that was basically a known good state because it's the version that Linux was using. And by using that device tree with seL4, we were able to kind of solve a lot of the issues and get virtualization functioning on the TX2 chip. The first portion of the project we just ran on the TX2 developer board, which is a deprecated piece of hardware. They came back and said, hey, can you run it on the TX2 NX? So basically, we just followed the process of creating a new sub-platform, provided the new device tree kind of using the same methods, created a new project, and we're able to get everything functioning on that new board as well.
How does this technology enable next-gen AI systems?
Just the ability to containerize an AI would be a good feature to provide an AI with a specific set of resources and not need to worry about it overstepping its boundaries, really.
What features are enabled by this combination of seL4 and NVIDIA hardware?
A lot of the times, customers will choose hardware based on what they're familiar with. NVIDIA is a large chip supplier. They have a lot of low-cost chip options, and they're optimized for use in fields like AI. You now can take an artificial intelligence application and secure it with seL4. And that kind of tells a good security story and a good innovation story as well. So that would be one of the big reasons why people would choose the NVIDIA platform is really familiarity, and they have a lot of cutting edge features. And seL4 on top of that just adds security and a formal verification story.